This is Agones, scaling multiplayer game servers with open source. I hope you're in the right place. If you're not, that's okay, you can leave. I'm Mark Mandel. I'm going to talk for a little bit. Then I'll be joined on stage by Carl Dion from Ubisoft, and then after that, Edward Chin from Supersolid. So if you want to talk about open source and multiplayer games and dedicated game servers, you should hopefully be in the right place. Cool. Before we get started, that's about me, but like, who cares? I'd like to know a little bit more about all of you so that we can sort of tailor this a little bit. Hands up people here who work on multiplayer games. Excellent, you are all in the right room. Awesome. People here who are familiar with like Docker or containers? A lot of you, badass, awesome. People here are familiar with Kubernetes? Lots of you, not all of you? That's okay, totally fine too. Awesome, all right, so that's pretty good. Before we get stuck into things, marketing gave me this slide. This is good. No, it is good. Actually, I've been super proud of the work that Google is doing this year across multiple product areas. We really have basically a suite of products that work across the games industry to help you create, connect, and scale. There we go. I said the words. We're good. Let's move on. All right, so let's talk about multiplayer games and all the good things therein lie. So I want to talk about very specific types of multiplayer games. Obviously, multiplayer is a vast and varied, ecosystem of things. Primarily, what I want to talk about is your fast-paced online multiplayer games, right? Your Fortnites, your Overwatches, your Rocket Leagues, that kind of stuff. We're going to actually see a demo a little later on. There's an open source game called Sonotic. It's a fast-paced FPS. Anyone here know Sonotic? People who know Sonotic because they've seen my talks before? Yeah, same group. Okay, cool. No, it is actually a really fun little game. We're going to use that as a demo, but it is very much that type of game. We're going to just set some basic foundational stuff for people who aren't as familiar with multiplayer games, but for some of you, I'm guessing this will probably be things that you're already somewhat familiar with. So when running fast-paced online multiplayer games, usually, and a fairly prevalent way of doing this, and there's a variety of ways, is doing it through what we would commonly refer to as a dedicated game server, or an authoritative server. So essentially what this means is you have a set of clients, say like 4 people playing a game, and they connect to some individual simulation server that sits somewhere on the internet. It's controlling the physics of the game, what players are doing. It's essentially the authority of everything that's happening inside the game. And usually players are sending in things like, hey, I did this thing, like I fired a rocket, or I'm moving forward, or I'm running now. And it's the job of the dedicated game server to do a lot of the work to determine exactly what's happening and send information back to those players to let you know, yes, you did hit this player, or yes, you scored a goal, that kind of stuff. There's a couple of good reasons for this, and this could be its whole other talk in and of itself. But the 2 big ones being that, one, having a dedicated game server gives you a bit more control over what's going on and can give you some avenues to stop cheating, because people are horrible and they like to hack stuff. And the other thing is that, unfortunately, we can't control the speed of light. It would be really nice if we could. So having control over the geographic region of where you put your dedicated game server means that you have some control over how much lag there's going to be between players based on where they are around the world, right? So if we want to play a game and like we're all in San Francisco, we want to put our game server in San Francisco, which is awesome. We probably don't want to put it in Australia. That would be bad because it's very far away, and then we get big lag time. So that gives us some control over what it is we want to do. So how do we run these? Let me put that on full screen. That's better. So traditionally, how do we do this? This is probably fairly familiar to a lot of people. We might have a couple of people who want to play a game. They usually connect to some kind of matchmaker. And the matchmaker's job is to group people by social graph and skill level and all that kind of good stuff. And then usually they talk to some kind of bespoke server manager thing, right? Wherein it says, cool, like I know about a whole bunch of like VMs or something like that, and I need to go find like some CPU resources and some memory resources and spin up this game server for a person to play on and find a port and do all that kind of work and do it across potentially thousands and thousands of machines. And then once I've got that game server up and running, I grab the IP and port or ports that it's running on, and I pass that all the way back to the players so that they can connect directly to the game and we can now play a game. That's a lot of work. So the part that Agones and the things that we want to talk about today is really like this part. how do we do the orchestration of game servers? How do we like find the right amount of resources to run our game servers on? How do we know that they're up and down? How do we make sure that we have lots of them sitting there waiting to do stuff? Like, how do we do that whole process? That's kind of a very foundational task that we all kind of need to do if we want to run dedicated game servers. And I think is also kind of a solved problem that lots of us have done over and over again. So having a single solution is super nice. So, speaking of single solutions, a few of us came together and looked at this and said, okay, there should be like a standard solution for us doing this. This shouldn't be something that we all reinvent the wheel over and over again. It's a foundational piece. It's nothing actually that secret sauce about how we do stuff for game servers and run multiplayer games. The actual games themselves and the pieces of the games, that's the secret sauce. So came together, built out a project, and Carl's going to talk a little bit about that a little bit later, between the collaboration between us and Ubisoft. But basically, yeah, we wanted to build an open source platform for you to run, host, and orchestrate your dedicated game servers across large clusters of machines. So my job here today is kind of to show you how some of that works and give you some background on that, and my follow-up people will tell you a bit more about the experience. So first things first, some of you are familiar with Kubernetes. For those of you who aren't familiar with Kubernetes, Kubernetes is another open source project that originally got started by Google, but it has involvement from Red Hat and a bunch of very, very large companies, and has been used a variety of places, including GitHub and eBay, and been running Pokemon Go, and you can read a bunch of stuff. It has become, I would like to say, almost probably a fairly standard de facto way of running large-scale distributed systems across large numbers of machines. If you're not familiar at all, just think of it as a way to programmatically and declaratively say, I want this software to run over lots and lots of machines. At a base level, that's what it does. There's more nuance to it than that, but that's basically what it does. And we're able to leverage this to run game servers. So there's a few really important things here that I think are worth mentioning, even if you're not that familiar with Kubernetes. One, Kubernetes, it's an open source project. Quite obviously, I work at Google Cloud. We have a managed version of Kubernetes called GKE. But Kubernetes itself is open source and will run pretty much anywhere. You want to run it on us? Perfect. You want to run it on your machine? Fine. You want to run a single cluster inside your QA workstations? Perfect. You want to run it across multiple clouds? Awesome. Right? So anywhere that your players are and you want to be able to reach them, you can put a Kubernetes cluster, which is great, right? Because sometimes players end up in strange places around the world and you need to run your infrastructure there. The other thing that I really like about this is also that it simplifies a lot of your systems. So I say this because Kubernetes is great for running your like microservices and that kind of stuff, your marketplaces and your auth, and that's awesome. But usually what I see when I talk to game studios and development shops is they have one system for all their backend services and then one completely different system for all their like dedicated game servers. My perspective here is if you can run the same platform for both, suddenly you can run the same tools, you can use the same infrastructure, you can use a lot of the same ecosystem tooling that you use across the board. And so suddenly you're like, okay, I don't need to relearn a whole new system to do these sort of things that are usually fairly interlinked. Finally, if you're not familiar with Kubernetes, like that is an ecosystem that has ridiculously blown up over the last 3 or 4 years. I can literally say that when we built Agones, we were standing on the shoulders of giants because there are so many people working on this project and so many people working on projects around this project that it enables us to leverage a whole bunch of stuff. So anyway, enough preaching. Let me show you basically how this stuff works. So potentially unsurprisingly, the first building block of everything is we put stuff in containers. This means that if you want to run a game server, we really aren't restricting you about how you do it. As long as you can put things in container, you're pretty much good to go. So as long as you can put stuff in a Docker container, it's great. We do have an integrated SDK, so there's an integration point with your game server itself. We have some pre-built SDKs that are gRPC based, which is just a way we do RPC calls. But if you don't like it, you can always use REST, so it's fine. Basically, the short answer is if you want to integrate with your engine, we can find a way. It's fine. It's all good. There's lots of ways we can make that work. And this is really just so that we can see what your game server is doing. Is it healthy? Has it started yet? Is it ready to take players? The game server can access its configuration for Agones, all the good things that it needs to be able to do. Okay, so let's actually look at like how we get game servers running on this. So Kubernetes itself, like I said, is declarative. Basically, we tell it to do something, and we trust that the system does it. And one of the lovely things about Kubernetes is it also enables us to extend it. So by default, Kubernetes comes with a bunch of stuff that works great for web servers, right? Fire me up 10 of these and make sure they stay up and also put a load balancer in front of it. That's great. That doesn't work necessarily for game servers. So when you install Agones, suddenly it has this new verb inside this configuration YAML files that we set up called game server. And now it understands how game servers work. So here, as I said, we have a game server. We're able to give it a name, or we can actually have Kubernetes create the name. There's all sorts of good stuff here. We can specify a port policy. So Kubernetes itself doesn't do dynamic ports. Agones will do that for you. So it'll do the routing for the ports for your game servers as they come through without you having to worry about doing any of that work. And then you can basically specify a set of containers or just a single container for a game server that runs your example. Here we're running Sonotic. It's a simple template that we have here. If you are familiar with Kubernetes, this is actually down here a full pod spec. So if you want to do volume mounts or config maps or multiple containers or anything like that, you totally can. It's all available to you. So this is cool. For sake of time, I'm not going to show a demo of this. This is just running an individual game server. Basically, you can spin it up and spin it down. That's cool. But what we really want, and I think for a lot of game server workloads, is what we actually want is large groups of game servers. So sometimes game servers take a little while to spin up. Sometimes they're a little slow. It's OK. So if you had a set of 100, say like 10,000 or 50,000 game servers or less, which is fine too, just sitting there waiting for players to come in, then we can manage that here with what we call fleets. So if you're familiar with Kubernetes, rather than having like pods and deployments, we have game servers and fleets. So a fleet is basically a specification of game servers, but we just say how many of them we want. So here we're saying we just want 2. Like, we don't have that many players yet. We just have 2 people. It's fine. And down here, we specify what our game server specification looks like. It's just an extension from there. Nothing too crazy. So now we can have big fleets of game servers. That's just super cool. We can scale them up as much as we need. But we need a way to atomically access a game server within that fleet. Right? So we need to be able to say, hey, I have a player, like say it's come from a matchmaker or something similar. I need to be able to be like, that whole big group there, please just give me one, and give me one in a way that makes sense for a variety of reasons. So we have this concept of what we call allocations. And allocations are actually kind of special, and they're kind of awesome. Allocations are primarily, I think you'll find, you usually do this through an API call. Everything I've shown you here is through YAML files, which is the declarative nature. Everything I do here, I could also do through an API call to the Kubernetes API. I don't have to do it this way. This is just easy to show for demonstrative purposes. But I'm able to do an allocation with this. So if I wanted to say, I want out of the Sonotic fleet, I'm going to send it an allocation. I'm going to do, here I have a variety of things I can do with allocations, but here I'm just saying, out of the fleet Sonotic, please give me a game server and set it to allocated. And allocated is special, right? Allocated is that special status that says, players are playing on this game, please do not delete them. Because players get mad if you just decide to delete games for some reason. And they post stuff on Reddit, and it's just no fun. No one likes that. And this is probably one of like the core things that makes Agones Agones, is that it understands that transition of state between, hey, I have a game server, no one's playing on it, who cares if it dies, to, hey, I have a game server, players are playing on this. This is now like really important, and like please do not remove this in any way, shape, or form. So allocation is the thing that allows us to do that. And we can actually do a whole bunch of things with game server allocation. We can do preferred sets. We can do like multiple requirements. There's lots of good stuff here. But essentially, we're just doing some label matching here, wherein we can have arbitrary key value pairs and whatnot. So I thought I'd do a bit of an extended demo and show you it in action and make it a little less abstract. So hopefully nothing goes wrong. Yes, awesome. So I have a Kubernetes cluster. It has about 20 nodes on it, give or take. This is the command line tooling. So it's all set up. I don't have Agones installed, so let's actually install Agones. We're going to use a package manager called Helm to install Agones, and I'm going to install it. Agones system, it's probably not be there yet. And it'll be Agones/Agones. So I'm going to install the production version of that, the most recent release, and that's pretty much there. That's pretty much what I have to do to install it. There's a few different ways we can do it. If we want to have a look, there's a few components that installs, a few different things there. Here we have the controller system as well as some latency measurement stuff that we have installed. But that's all good. That's pretty much what I had to do to install. So if I want to create a fleet, we can use the same YAML file we did previously. Again, we could do this through an API. We could do this a bunch of different ways. So example synodic fleet.yaml. And we can enter that here. So this is quite cool. So we installed Agones, and that installed those extensions we were talking about previously. So now we can actually say things like, hey, Kubernetes, show me the game servers that are in your system, and show me the details about them. That's something that Kubernetes didn't know about before. But now it's integrated directly in our tools. They're spinning up on, I think, some new clusters. They'll come up in a minute. Of course, it's a demo, so something's, yeah, they're just pulling down. That figures. They'll come up in a minute. But we can see things here. So we can see like what address and what port they're on. They're currently scheduled. They'll kick over to ready in probably about a minute once everything's happy. And we can kind of mess around with this now and see it in a variety of ways. If we want to have a look at it as a fleet, for example, right, we can see here that there's 2 currently desired, and they'll soon be ready. The synodic image is like 1.5 gigs, and so it takes a little bit sometimes to pull down to machine. But it'll be there in a minute. And we can see some various things on here. So if we want to scale this, we can do so. So let's just scale the fleet. kubectl fleet. I'm typing down here, so it's always fun. kubectl fleet, synodic. Oh no, I know what I did wrong, sorry. Scale. There we go. Now we get the completion. Synodic. Replicas, we'll say 200. Right, so that'll start coming up. So now if we say get fleet, right? Oh, good. The 2 finally came up. They'll come up pretty quick, but we can see that that's gonna start to grow. If we want to have some fun, that should be green now because we've actually got that. We can start actually seeing dashboards for. Is that going to work for me? Or did that crash? Hehehe. Of course, demos, right? Can't trust them. There we go. Awesome. So that's not working again. We have pre-built Grafana dashboards and hooks into a Prometheus. So we use a library called OpenCensus for doing our statistics and metrics. So you can use either Prometheus or Stackdriver if you want, or pretty much anything that OpenCensus will support. So if we want to have a look here and have a look at our number of game servers, for example, that is tiny and you can't see anything. But you'll start to see the number of game servers start to grow. This is usually running a little bit slower than what it actually is happening. And we can start to see things like how fast our game servers are coming up. We can start to see rates of what state they're in, what fleet numbers they have, how they're distributed across our cluster. There's a variety of different types of statistics that we're able to take advantage of, which is really, really nice. They're starting to come up now. There we go. We have about 100 or so. That's pretty nice. So we can do all sorts of fun things here as well. So if we have a look at our fleet, there we go. We got about 106 ready. That's much better. They're coming up pretty quick. So let's actually do an allocation, and we'll play with that. So kubectl create -f example synodic game server allocation. So again, you would probably do this through a Kubernetes API call, but we're going to do this through this just for demonstrative purposes. And I'm going to tell it that -o YAML basically says the result that you're going to send back to me that usually would be JSON, just put it out as YAML on screen so we can see what it's doing. So we can run that, and that's going to basically give us back an allocation, and the bit that we care about is really this here. So it's going to take one of those game servers out of that set, look through them all, basically look at how many we have available, and grab the one that is ready and sitting there waiting to be played on. So, and give us back the address. So we can see here that that's on 35236.122. That's the game server name that we had previously, and there it is, state is allocated. So let's play a game. Is that going to open on the right window? It is, yes, awesome. I'm just going to move that over a little. Perfect. 3, 4, let's see if I can type this correctly over my shoulder. Nope, I can't. 122.169:7353. Let us see how the internet is here. That is actually good. Yep, my mouse has disappeared. Here we go. Yep. All right, so I'm just going to play that in the corner. So this is me. Hold on. This is me trying to play Synotic. Oh, I see. It still has the settings where I dropped all the weaponry, so I could take screenshots, but that's all right. But this is me playing Synotic on Agones, running on a cluster in the cloud. Basically, this is running on a GK cluster on US West. We have some bots running around. I am terrible, clearly, because apparently I'm underwater for no apparent reason, which is fine. Where am I? And also trying to play on a trackpad. I'm going to blame it on the trackpad, mostly. Oh, come on. There we go. Thank you. I'll let someone kill me. Where's some of those? There we go. So we have a few people coming and playing against me. But yeah, this is running up on Kubernetes. It's all working really, really well. And we're able to play a game, which is super nice. I'll show you some other fun things while we're here. So you can start to see some more fun things in the graphs now that take a little bit of time. But like we have 199 already sitting there. You see it up in the top left-hand corner. That's all green now. We can start seeing some more things here about our rate of stuff coming up, as well as how many are ready. We also have auto-scaling capabilities, which I'm not going to talk too much about today. We have graphs for that, all that sort of metrics. All the stuff that you kind of just need to have to run game servers and make that really important stuff without like you having to do the work to write all this plumbing type of code. So there's a lot of really cool stuff inside Agones. So hopefully that gives you a bit of an idea of how that whole system works. If we come over here again too, we can also have some more fun because we have some time. I can scale this back down. So if I say scale fleet Synotic replicas, say I want to make that 0, that's going to start deleting game servers. But we have one game server that's allocated, and so we don't want that one to die. And so what we'll actually see is, yes, it will go and get rid of all the game servers that we had have previously, but it won't touch that one game server where we have players on it. So that's super important. So even if we are editing our fleets and we have like a rolling update rolling through, which is something we support, or you want to scale a fleet to adjust workloads based on, say, maybe you have less players coming in, you always know that your players are safe on that game server. See how quickly that comes down. There we go. And so we have that one allocated now. Like that never went away. That always stays there. That's super important. Cool. So that was me showing you how some of that stuff worked. That means now that when you have players that want to play a game, rather than connecting to some bespoke system, they can take some sort of custom matchmaker, potentially OpenMatch for some strange reason, also a fun project we work on. But they can talk directly to the Kubernetes API. They can reuse all the stuff that Kubernetes API gives you, right? As soon as we install Agones, right, the tooling changes, the API changes, it understands how to manage all these things. And then the Kubernetes API can be like, hey, Agones, right, like, I'd really like a game server to be allocated to me, please. So cheers, thanks, I appreciate that. And then the information can be sent back to the players, and the players can play a game. And so you really can just focus on what that game server is doing and how it works, rather than having to worry about how it spins up and spins down. All right, enough of me. I'd like to introduce Carl Dion to come talk about how things are going over at Ubisoft.
Hi. For some reason, Mark and I have similar t-shirts. So I'm Carl. I'm Director of Development at Ubisoft. I'm responsible for the multiplayer products, multiplayer services in the online group. So that's mainly the network code, matchmaking, as well as the server allocation products. So I work at Ubisoft. You probably know Ubisoft. We're third largest publishers. We have a bunch of people, 14,000 employees, and that's growing. So it's pretty big companies. You probably know our games. So today I want to talk a bit about why we actually were interested to collaborate on Agones. And let me start by talking a bit about the change that's happening in the industry today. Like if we look back, it's not that long ago, releasing the game used to be the objective, and now it's just only the beginning. Like players are expecting to see their games as a service. It's not just a box product anymore. They want to see a service. They want to see a game that keeps changing all the time. They want to be surprised by new content whenever they log on onto the game. So that game as a service trend, it's something that continues and accelerates. And I think that when we look at cloud gaming, for example, to me it's just an extension, natural extension of this. That's the way that players want to have their game. So let me talk a little bit about what the impact it has on our games. So when we look at the game, I actually have the game client. So what's a game client? Well, it's a thick client. It can be pretty big. Like when we look at the latest Assassin's Creed, let's say 42 gigs client. So that's pretty big. That client is going to connect to an ecosystem of services that will be running. So that includes stuff like matchmaking, challenges, stats, whatever. And as we are building rich games as services, it means that that ecosystem of services is becoming richer and richer, because that's one good place where we can deliver value and content to our players. One thing that we see as well is if we're going to build that type of games, it means that we need to have content that will be available for the players for a long time. Okay? So an easy way to make a game that will have like hundreds of hours of gameplay is to make it a multiplayer game. So that's the reason why we see a lot of multiplayer games nowadays. We see, and so typically it means that you're going to need to have the game, a game server to actually host that multiplayer application. Now, that's going to come with a number of challenges. Like first, we need to be agile. We need to be able to adapt super fast to the needs of the players. And that's true across the entire ecosystem. Like, we know how to be fast at deploying new services, but we also need to be able to do it through the game client and the game servers as well, to be able to deploy new content. Another challenge that we have as well is the question of the scale and the question of proximity. We want to make sure that these game servers sit very close to the players, because if latency is high, that's going to have an impact on the performance that they see. When you think about scale, game servers are pretty CPU intensive. To give an idea, at Ubisoft, we currently peak at about 100,000 virtual machines to run our game servers. And when you look at that, like having 100,000 virtual machines across like dozens of data centers, that's a pretty big number. That's going to be close to the capacity of many data centers that you see. So that makes your typical blue-green deployment quite of a challenge. And so in that context, making that type of game is becoming increasingly complex. And I think that collaboration is something that is important. It's a nice slide, eh? It's a bit cheesy. I think that we could make a nice poster, you know, like you have gotten these nice motivation posters. But seriously, collaboration between our teams at Ubisoft, collaboration between the brands, and collaborations with other people in the industry or outside of industry, I think it's something that's very important. And that's basically how Agones was born. So a while back, it's about like maybe a bit more than a year ago, we knew that Stadia was coming, and I was talking to Mark, and for some reason, like if we look at Stadia and we have the games client running on GCP, it makes sense to have the server running in GCP as well. So I was talking to Mark and said, hey, what are Google's plan regarding game servers? And we chatted for a little while, and we realized that we had a very nice collaboration opportunity. Or basically, we could say, well, let's put together the knowledge of Google for what it means to be able to scale and deploy containers at scale with Ubisoft's expertise of what it takes to actually build and manage game servers. And that's basically how Agones was born. So it's an open source project. It makes it possible to deploy game servers at scale across Kubernetes. So it actually was a nice collaboration out there. So one thing that I really like is, since Agones is based on Kubernetes, what do we get? Well, we actually have a lot of flexibility, because now we can actually deploy these game servers across different type of clusters. So we can go, for example, to, we can deploy them on physical clusters, and that's a good way to save the cost, and that's important. And when we have a spike, then we can actually go on the cloud to handle to be able to handle the burst. So Agones is something that's part of a wider ecosystem at Ubisoft. We have, it's part of a complete ecosystem made up of hundreds of applications and microservices to manage the online at Ubisoft. And I think it was a pretty good example of collaboration between two companies. So, thanks.
Hello. Hi, I'm Ed. I'm one of the co-founders at Supersolid. Apologize for not being on brand today with the Agones t-shirt, but maybe later. Yeah, so in the next 5 to 10 minutes, I'm going to tell you a bit about one of the games that we have in development. I'm going to go through why we decided to use Agones, how we're using it, and also a bit about our experience with it so far. So quickly, first, a bit of background. Supersolid, we're a team of about 40 people. We're based in London in the UK, and so far we have these 5 games. So our first 2 games, Super Penguins and Pororo Penguin Run, are both infinite runners. We've got Adventure Town, which is a town-building light RPG game. And then our 2 most recent games are Food Street and Home Street. They're resource management simulation games. As you probably noticed, none of these are multiplayer games, or at least not real-time synchronous multiplayer games. But that is what we currently have in development. I can show you a bit more about this game. It's called Snake Rivals. And here is a short teaser, which I might need Mark to play for me. Great, thanks for that, Mark. So thanks. That's our latest game. It's out later this year. It's called Snake Rivals. It's our first real-time synchronous multiplayer game. The idea is that there are 50 players all in an arena at once, and we've got these 3 different modes. There's a classic mode, which is kind of similar to an IO game, if you like. So players come in, and the session ends when they die. And then we've got 2 other modes, a Gold Rush mode and a Battle Royale mode. In Gold Rush, it's more timed, so you're In more strategic gameplay, you're trying to make kills or steal kills, and at the end, the player who has the most points wins. And the third mode, Battle Royale, I'm assuming that everyone knows what that is, and basically the last surviving player wins. So about, I guess, 12 months ago, a little less than that, we decided to make this game. The first question, I guess, was, well, how are we going to build it? And quite quickly, we decided to use Kubernetes. So the big question for early research was what implementation of Kubernetes we wanted to use. We settled on GKE, which is Google's implementation of Kubernetes. We did that for a few reasons. I think we tried it out on a few different services. With GKE, we found it was just the easiest to set up and get running. There were also kind of a few other advantages that we liked. The ease of using the GCP services, such as load balancing as well, that was pretty important to us. Debugging live code, easy error tracking of live incidents, and also we found it's also relatively cost effective, which is also something important to consider. So, having decided to use GKE, we found that we also had 3 key requirements. This is stuff that I guess Mark went through earlier, but is pretty important for these multiplayer games. So the first thing is that we've got to be able to start up game servers on demand. So in the endless mode, for example, when the arena fills up with 50 players, we need to start a new arena. So we need to be able to start a new game server. And for the other modes, when players want to start a new game, again, we need to start up game servers on demand. And when the games are over, when they're finished, we also need to be able to shut them down. The second requirement, which I think Mark touched on as well, is to be able to protect running servers from shutting down. So this is pretty key. So if a service gets updated, for example, you don't want your game servers to shut down because everyone, well, all your players currently playing will get kicked off their game, and then your Google Play rating goes down, and that's always a terrible thing. Then the third requirement is, of course, the scale based on demand, so number of players and their location as well. And well, what we found was Agones just helps solve all of these issues for us, and that's the main reason why we decided to use Agones. Moving on to exactly how we're using Agones. So this is kind of what's going on with Snake Rivals. So when you start a game, I guess the client asks for the game mode, so whatever game mode the player asks for. That then goes to the Google Global Load Balancer, not the easiest thing to say. And that asks for the matchmaker, also selects the best cluster for the client to connect to. The matchmaker then finds that specific game mode, a game for that to join. And Kubernetes, via REST API, gets the list of game servers, and that's managed by Agones, which maintains the pool of game servers. The matchmaker then decides from the list of game servers, and again, via REST API with Agones, we mark that selected game server as allocated so that, importantly, it doesn't get destroyed. The matchmaker then returns that one game server to the client, and the game starts, and the player obviously has a great time playing the game. And when that game finishes, again, via REST API and Agones, we then mark that server as shutting down. And that's at a pretty high level how we're using GKE and Agones. And so finally, I guess, it's a question on how we're finding it. And yeah, it's been pretty great so far. We've seen that it's a pretty supportive environment. So there's a Slack group that's pretty responsive. There's a Google group. There are community meetings that happen quite regularly. It allows us to influence the roadmap of what's being produced, prioritization of that as well. And then obviously we're able to report any bugs that, that we come across. So that's been great. We've also, through this, I guess, built a great relationship with Google. That's given us great access to training materials, so courses and Kubernetes workshops as well, which has been really positively received by our developers. So thanks for that. We've also had access to a production readiness review, and that's been really useful. So they assess the game architecture, and they give suggestions, I guess, on how to operate at Google standards. That's the SRE methodology. All of this is just super important to us because, I think all game developers here just know how hard it is to develop a hit game. And once you have that, you just want to make sure that everything scales properly and all your game servers are up and running. I guess finally, you probably have to say something negative. If there isn't anything negative at all, the only thing is to point out it's an alpha service, so you might get what you expect from alpha services. If a feature gets deprecated, you might have to code around that, or you might be working away at a feature and then you realize that actually that's what they're building next. But you know what? Like it really doesn't matter to us. The communication has been great, so we avoid a lot of these issues. And also, if we weren't using it, we'd really have to build it ourselves anyway. So for us, it's really has been a no-brainer. So to sum up, so with GCP, with GKE, Agones, it's really been able to allowed us to be able to build Snake Rivals with a relatively small team, probably just two server developers in under 12 months. So that's been great. Thanks, and look out for Snake Rivals coming later this year. Thanks.
Thank you so much, Ed and Carl, for joining us. Want to make sure we have plenty of time for questions as well, but some things to talk about as well. So before we wrap up, there's some things I want to mention. So I gave you all a brief overview with Agones. If you haven't looked at it in a while, it's definitely increasing at a fairly rapid rate, which is really great. But there's a lot of other features that we didn't get to touch on today, including the fact that it works across cloud providers, right? We work against vanilla Kubernetes. That's very important to us. We want to make sure it works everywhere. We didn't talk about auto-scaling, but that is something that is ingrained and inbuilt. So we have fleet auto-scaling. We work directly with the standard Kubernetes autoscaler as well. So it does cluster auto-scaling. Hello, GDC. So that's all available as well. We have a suite of local developer tools. So for example, if you don't want to run a full Kubernetes cluster on your own machine, you just want to do some light testing, we can do some SDK local tooling, things like that. So make that a little bit easier for you to do. And I showed you some of the metrics and dashboards, but there's a whole suite of more metrics and dashboards that you can use, and that's an ever-growing thing that we want to keep expanding on, because it's the second day and the third day things that really get you, right? It's the stuff that making sure you know exactly what's happening in your system on the launch day, and then the day after that, and after that really kind of gets you as you go through. On the roadmap coming forward, I would actually say, I just want to be very clear as well, like on the roadmap, we are very directed by our community. If you're here now and you're interested in the project, I would definitely love to say, like, come in, try it out, provide feedback. There are a lot of features that are getting developed right now that maybe a month ago we wouldn't have even looked at, but because the community got involved, we started to look at it and be like, oh, this is a thing that's really important. Like, a lot of us have shifted gears, changed priorities, really worked with other people who are using the tooling to really build the things they need, so that's definitely a big thing. Things highlighted, we've done a bunch of performance improvements in the last few months that have been great, but we're looking to do some more that are coming up. Again, like I said, more metric collection and display. Ops is hugely important. We've got some commercial engine integrations. Right now, if you want to run like Unity or Unreal, you kind of have to hook into our REST API. It's not the cleanest, but we want to have some stuff out of the box. You can still do it, it's fine, but we want to make that a smoother experience. Oops. Multi-cluster. Multi-cluster is also front of mind. Right now, it's fairly focused on like individual clusters. We have some design tickets around right now for doing multi-cluster allocation, and it's some other things around that we're looking at. Potentially working with some of the SIG multi-cluster things. There's a lot of work going on in the multi-cluster space for Kubernetes, so there's plenty of space there to grow. Windows hosting is something I also get asked about a lot. Generally speaking, we are leaning on the work of the Kubernetes community, so if anyone's here from Microsoft, please keep doing the good work you're doing with Windows. Thank you, we appreciate that. As soon as that stuff bubbles up into the Kubernetes ecosystem, then we were able to do that. We realize that's important both from a development perspective, because a lot of us work on Windows and we just want that short iteration time, but also there are people who run production workloads on Windows, and that's totally cool as well. So we want to do that. Definitely a lot lost. If you're interested in Agones, we actually released this just the other day. So if you want a very quick way of getting an Agones cluster up and running for test purposes, you can actually go to the Google Cloud Marketplace. You'll see there's some documentation there, and you can go search for Agones, go through, and it'll create a cluster for you. You can actually do the installation right there. It's basically a one-click install. I would say it's generally used for testing purposes. We have some hardening rules that we do in production that we couldn't quite do yet in the marketplace, but we'll get to at some point. But if you just want to be like, hey, how does this thing work? How can I use it? Let me try it out. This is a great place to start and get your feet wet. Lastly, I will say very quickly before we get to questions, we've got plenty of time for questions, which is great. My business cards are up here at the front, along with a whole bunch of Agones stickers, if people like stickers. I hear developers like stickers. My business cards are here, so please feel free to come up and grab one. If you haven't got questions right now, but you think you might, say a week from now, 2 weeks from now, a month from now, please grab my details. Come join us on Slack. Come get involved on GitHub. We'd love to have you. But if you want to learn more, the website is up there at agones.dev. Please follow the Agones Twitter on Agones Twitter. If you want to learn more about Kubernetes, Kubernetes.io, and Google Container Engine. Before we wrap up and I open the floor for questions, thank you all for coming and hopefully enjoying yourself with us. I know all your time is valuable, so I appreciate you all coming and spending your time here. So without further ado, if anyone has any questions, I would love to hear them. If you want to come up on stage too, we'll do that. Questions over there. Two questions. So the question was, does the Docker container set any hard limits? Not really, no. As your Docker containers get larger, they can be unwieldy. There are some strategies we do have that we're starting to talk about internally about how to share assets between containers and how to load them up quickly. We can do some in-memory mapping type things. That's another area we want to explore as we go forward too. A lot of people in development just build really big containers, like 3 gig, 4 gig containers, and it's fine. They just transfer over the network a little bit slower. You had another question, I know. Oh, there we go. Perfect.
The automatic port allocation that you showed.
Yep.
Can you just talk a little bit about that?
Okay, so the question about how we do port allocation. Basically, the way we have it set up is for each game server, it sits essentially within its own network namespace. So what we do is the container starts up, and it's whatever port that you tell it that it's going to start up on. So they all start up internally the same. And we set up Kubernetes. We set up a Kubernetes host port, basically, which what it does is it'll set up a IP tables route that runs through the node and then directly into the container. We found through testing, it's like worst case scenario, it even doesn't hit that very often, about half a millisecond. But it means then you can still run sidecar containers, you can still run other services alongside it and know that is contained within the network namespace, so you can do some really nice stuff that way, and it was a nice trade-off that way. I think there was you who had a question next.
Sorry, I just think I just missed the what you're. Is that the free to download, or do I need to buy the trial?
Oh, for the marketplace? Yeah. Oh, that's a good question. Like, how do I work it on the marketplace? So if you want to install it on Google Container Engine, we have a $300 free trial that is valid for up to 12 months. So you can go use that. If you want to do it locally, you can do it locally. If you want to use, there's a couple of local Kubernetes tools, Kind, K-I-N-D, or Minikube. So you can install either of those locally and then install Agones on that, and that's not going to cost you anything.
I was thinking, try to testing, multiplayer game for my own games for just, future.
Yeah, so you could do either of those. You could test it locally on your machine or run a trial account on Google Cloud.
But I was also thinking about it. I'm attending a school at the Academic Art University, and then it's just testing the different computer that, hey, can you hit me or something, and then boom, it does affect you or something. That's what I was planning for, you know.
Okay. There was, I think, someone back there. I'm staring this way. I need to turn that way next.
Hi. So it seems like a lot of the kind of architecture we just talked about is useful in an example where you spin up a pod, you allocate the players, and it tears down in a traditional multiplayer setting. But how does this kind of work where you might need inter-pod communication in something like an MMO where instances are just constantly being spinned up and for different players and different zones and that sort of thing?
That is an excellent question. So how does this work in an MMO context? So we have been relatively focused on more of a session-based thing. I definitely want to explore, or I think we definitely want to explore, I should say. We definitely want to explore how we can support more MMO type stuff. The nice thing about Kubernetes is the way it's set up with its networking model from foundation is that all pods can talk to each other. So all pods, as long as you have the IP address of the pod, you know you can actually communicate within the networking system within the cluster. So that sort of stuff is available to you. But I actually do want to explore more if there are things that we can do at more of that foundational sort of orchestration layer of like how can we, and I don't know exactly what that looks like, but how can we do like, I don't know, help you with like geographic splitting or that kind of stuff. That being said, there's nothing that necessarily stops you from doing that. Like you can leave these up for as long as you like if you want. They don't necessarily have to come down in 3 minutes or 20 minutes or an hour. Like as long as you want to do a little bit of extra work over the top, you can still use them for doing MMO type stuff. There's nothing inherently there that stops you from doing that.
Okay, so I have one more. So you talked a little bit about hosting on Windows.
Oh yeah.
I was just curious about how much exploration you've done in terms of like nodes that are Windows in Kubernetes clusters, but then more importantly, Windows containers. Specifically because we work on the tools for PlayStation development, where most of it happens on.
I have not explored
Windows.
that really at all. There is a lot of work that is happening with running Windows containers inside Kubernetes. I'm not an expert on that area.
Okay.
There's a whole SIG for it. There's a whole special interest group for Windows on containers. As far as I understand it, it is coming. They're working on it. It was required. There was some requirement for some early release type stuff on Windows to get the Windows container support needed for Kubernetes coming through. But it is coming. It's just a question of when it gets done.
Is the answer just go talk to Microsoft guys?
Sorry?
Is the answer just go talk to the Microsoft guys?
There's a SIG Windows group. In Kubernetes. So Kubernetes, the way the actual open source project is structured, they have special interest groups for different areas. So you can go on Slack, you can go on the mailing lists. They have regular meetings. So basically you can go see what the structure is there, and everything's like available. It's all open.
Okay, awesome. Thank you.
Yeah. It was over here. I've been facing on the other side.
How does this fit in with Stadia?
How does this fit in with Stadia? I actually, that took longer than I thought it would to ask. The short answer here, I think, is Stadia's, like, I'm not going to talk on behalf of Stadia because that's not the product area. But the short answer here is we talk a bit about our network, essentially. And so if there are instances which you are using Stadia and you want to have a dedicated game server, running it inside Google's network is ideal because we don't have to go outside. We're inside our own network. Our product manager was talking about this earlier this morning. There's a lot of inherent speed and cost savings you can do there. So there are some instances where you may want to run a dedicated game server. But yeah, that's just, we allow you to do that, and so awesome. That's the short answer. I figured I'd get that question like first. We have a couple of minutes. Someone over there.
Hey, thanks for giving the talk. You mentioned getting some of the metrics out of Agones, but what I'm kind of more curious about is managing the complexity of Kubernetes. Are there any good tools for like pulling out, stack traces of server crashes or things like that that you know of presently?
So generally speaking, as long as anything goes, any text goes. Actually, here's an interesting question. How do you dump your server traces now? Is that just straight to like a text file? Does it come out to logs? Are you like doing like heap dumps?
Logs that are then picked up by an external.
As long as any log. Speaking of, let me try this sentence again. Speaking for Google Kubernetes engines and generally speaking on Kubernetes as a whole, if you spit your logs out to foreground, right? So basically to standard out, then they get aggregated and sent to a central logging service. If you're running on Google Kubernetes engine, it's already set up so that, or Google Container Engine, sorry, that was the old name. It's already set up so that all the logs that go to foreground go to Stackdriver, they're searchable, you can output stuff. So that's all available to you just as standard log aggregation. And like I said in the talk, right, standing on the shoulders of giants, like that stuff we didn't have to do. It's just great. Like it's just there. It's awesome. I mean, even in Agones itself, we actually spit out JSON logs. So we do structured logging, and that goes straight into Struct driver, and it's like, oh, it's JSON, awesome. And now it's all like searchable, and it's fantastic. So I'm super happy. It's not work we have to do.
Cool. Thank you.
We have 1 minute and 22 seconds. No pressure. Going once, going twice. Awesome. Well, again, thank you so much for hanging out. Stickers and business cards are here. Hopefully, and if you want to chat more, we'll be around at GDC. So thank you so much.